Morning. Today we're going to evaluate a very common trigonometric limit, very typical exam question, and one that a lot of people get the right answer on but get it the wrong way and therefore lose points, if not all the points, at least the majority of them. When we evaluate the limit, we're going to use two limits that you should have memorized, which is the limit as u goes to 0 of the sine of u over u equals 1, and the limit as u goes to 0 of u over the sine of u equals 1 as well. And the limit we're going to evaluate is the limit as x goes to 0, the sine of 7x over the sine of 3x. Many people, by what rules I'm unaware, decide that they can pull out the 7 and the 3 from the sine expression, the sine function there, and then I don't really know what they do. They end up getting 7/3 as the limit, while in fact that is the limit. That's not the way you evaluate this limit, and you will get it wrong on an exam. I can't imagine any professor giving you any points whatsoever for completing that way, although maybe they're nice, but I certainly wouldn't if I was grading a paper. So here we go. The first thing I'm going to do is to rewrite this a little bit, and hopefully you won't have to do this many steps as I'm going to demonstrate here. Once you understand what's going on, you'll maybe do 2, maybe 3 steps in order to do this. But I'm gonna begin by just splitting up this numerator and denominator into a product of the sine of x, and I'm just going to write it over 1 to emphasize that there is a denominator of 1 there, times 1 over the sine of 3x. And now, by saying that we know that the limit of a product is the product of the limits, we know that we can actually evaluate these limits individually and then multiply them together to get what our limit is. But of course, in this form, nothing's is going to work. Let me rewrite that 7 so that it's a little more clear. Now what we can see here is that if I had a 7x in this denominator, well, I'd have this form. And if I had a 3x in this numerator of this part, I would have this form. But we can't just go adding in 7s and x's and 3's without compensating in some way, but we can multiply anything by 1 in the form that could look any way it wants, as long as it's equal to 1 and not change the value of this expression. So what we'll do is I'll just first recopy what I have there. I have the limit as x goes to 0 of 7x over 1 times 1 over the sine of 3x, and I notice that I'm going to need an x in the denominator and an x in the numerator, so I can multiply by x over x. I don't even have to worry about anything because I needed 1 in both of them. X over x is 1, so that takes care of that. I'm going to need a 7 in this denominator, so I'm going to multiply by 7 in the denominator. I can't just go around multiplying 7 to denominators, but I can multiply by 7 over 7, which is 1. Same thing here in this numerator. I need a 3, so I'm going to multiply by 3 over 3. Now I'm going to put things together. I'm going to use a little color here to emphasize what's going on. I'm going to take this 7 and this x, and I'm going to put it here. So I'm going to rewrite the expression, the limit as x goes to 0 of the sine of 7x over 7x. I've just reordered the x and the 7. And then I'm going to take this 3 and this x, I'm going to put them together, and I'm going to put them right here in this numerator. So that makes this expression 3x over the sine of 3x. So now I can use both this fundamental trigonometric limit and this one. And then what I have left over, I'm just going to write just a constant, and I'm going to put it right here. and that is multiplied by 7 over 3. Now we take our limit. The limit as x goes to 0 of the sine of x over sine of 7x over 7x is, as x approaches 0, 7x approaches 0, so we have, as the limit as u approaches 0 of the sine of u over u equals 1, so we can say this part of the limit goes to 1 times 3x, the limit as x goes to 0 of 3x over the sine of x, as x goes to 0, 3x goes to 0. So we have the same form here as we had the limit of, as u goes to 0 of u over the sine of u equals 1. So this also equals 1. And then the limit of a constant is just a constant. So we have 1 times 7/3. So the limit as x approaches 0 of the sine of 7x over the sine of 3x equals 7/3. You cannot just write 7/3 and get it right. You would have to show, I would say, if you went from this step to this step, you'd be fine, because at least the instructor would know what you were doing. Well, and of course, you know, evaluating the limit. But if you 1, 2, 3, you don't necessarily have to do this step and this step. This was for demonstration purposes. Although if you did all those, they would know exactly what you were talking about. That's it. Thanks.